All right, in 7.3c, we're going to talk about unit vectors and linear combinations. All right, so a couple new terms to us. A unit vector, here we go, is means it has the same direction as a given non-zero vector, and it has a length of 1. Okay, to do this, you can divide the vector by its magnitude to obtain its unit vector. All right, what the heck does that even mean? Well, let me show you visually what's happening here. All right, if I have a vector out here, let's say it's at 4, 4, the unit vector would be where it is a length of 1. That's the unit vector of it. Okay, that's the unit vector. So, and to find that unit vector, here's what we're going to do. We're going to take the vector divided by, so each x and y component divided by the magnitude of the whole vector. Okay, it says find the unit vector in the direction of the given vector. Verify the unit vector. That means you just show that it actually has a magnitude of 1. Okay, so it's saying at what xy coordinates is the length equal to 1 on that vector. All right, so if we think about this vector at -2, 2, okay, according to the unit vector formula, I need the magnitude of v, right? So I'm going to use my distance formula. Since it's a component form, I don't have to do any subtraction. So that's going to be 4 plus 4, which is going to be the square root of 8, and that does reduce to 2 square roots of 2. All right, and that's helpful as we do the next step. So then my unit vector is going to be -2 over the magnitude, 2 square roots of 2, and then +2 over 2 square roots of 2. Okay, now notice what's going to happen. These 2's will cancel. That reduces to -1 over the square root of 2. And for now, we don't have to rationalize. I know normally we would rationalize, but for right now, we don't have to. And this would be +1 square root of 2. Okay, so we're saying this is my unit vector. Now I have to verify it. Would the magnitude of this vector be 1? So let's just see. Would the magnitude of u be 1? Let's see. So -1 square roots of 2 over square root of 2 squared plus 1 over the square root of 2 squared. What does that come out to be? Well, let's see. 1 squared is 1 over square root of 2 squared is 2 plus 1 over 2. What is that? It's the square root of 1, which is 1. So we've verified our vector. And again, what is that saying? Well, that's saying our vector that was at -2, 2 has a length of 1 where it's -1 squared over square root of 2 and 1 square root of 2, 1 over the square root of 2. So it's a little bit more than 1 is what that comes out to be. There's your length of 1. And that makes a little sense visually. Hopefully you see that. Now, the unit vectors, it's a different topic a little bit. The unit vectors 1, 0 and 0, 1 are called the standard unit vectors. Okay, standard unit vectors. And they're denoted by this. Okay, we use I to indicate 1, 0. What does that mean? Well, that means I is 1, 0. That is the horizontal component, right? So this is the horizontal, or the x value, if you will. J is the 0, 1 component. So it's the vertical. All right? So we can rewrite a vector in what we call linear combinations using this. So look at this. Just follow along. So if a vector is v1, v2, and we take that v1 and we use it as a scalar on that horizontal, what happens? Well, x becomes v1, and we put the I on it to indicate horizontal. All right? And then the same, the v2, or the y value of that component, multiplied by j, the vertical component, gives us v2j. All right? So the scalars v1 and v2 are called the horizontal and vertical components. The vector sum then looks like this. Okay? It's just another way to write a vector. All right? And you'll see it as a linear combination. This is called, here it is, It's called a linear combination of the vectors I and j. Any vector in the plane can be written as a linear combination of the standard units I and j. Okay, so we're going to put a pin in this linear combination idea. We'll come back to it in another example. Just wanted you to know what it was when we get there. So now here's an example question. Find v with the given magnitude and the same direction as u. So I need to find some things about the unit vector. I need to find the vector u, unit vector of u, and then multiply that unit vector by the magnitude of v. All right, here's magnitude of v, so that's going to become my scalar. But I need to find the unit vector of u first. Okay, so the unit vector of u is going to be u over the magnitude of u, right? Well, let's find the magnitude of u. So it's negative 3 squared plus 4 squared. That's 9 plus 16, which is 25, right? So that's going to be a magnitude of 5. So then the component form, or the unit form of u, will be negative 3 over 5 and 4 over 5. Okay, there's my unit vector. I'm just labeling it just so you know what we're doing. Then it says to multiply the unit vector by the magnitude of v. So I'm going to take 10 times this and see what we get. All right, when I do that, what do I get? I get negative 30 over 5 and 40 over 5. And I can clean that up, reduce it down. So I have negative 6 over, and 6 and 8, sorry, negative 6 and 8. This gives me v, right? Gives the same magnitude as u and same direction as u. Okay? Now, let's try another one. Same idea. Notice this one's given to us in linear combination form. So the first thing I need to do is find the magnitude of u. So I could have written this as 3, 4. All right, don't let the I and the j trip you up. That's just 3 and 4. So what did we do? We 3 squared plus 4 squared gives us what? 9 plus 16 is square root of 25. So my magnitude is 5. Looking very familiar here, doesn't it? So then u, my unit vector, would be 3/5, 4/5. All right. Then it wants me to multiply by the scalar of the magnitude. So I'm doing 7 times 3/5, 4/5. And then my answer would come out to be 21/5 and 28/5. Yes, it's a fraction, but it's still okay. All right? Now, look at this next couple examples. Find the component vector, then rewrite it with I and j. All right, this is back to our first lesson. To find the component vector, we always subtract the x parts and the y parts, starting with the terminal. So what am I going to do? I'm going to take 4 minus negative 3, so plus 3, 5 minus 1. So that gives me 7 and 4, right? And to rewrite it with I and j, remember, this is just going to be 7i plus 4j. The vertical gets the j, the horizontal gets the I. So I would just say v, bold it v out, and there it is, 7i plus 4j. Same idea here. We're going to start with our terminal, 0 minus the 6, so minus the negative makes it plus 6. 1 minus 4 gives me 6, negative 3, right? And then to rewrite that as a linear combination, it's going to be 6i minus 3j. That's all it is. Now look at this. Find the component form of v. All right? Given that u is 2i minus j, w is I plus 2j. Okay? So notice what it's asking us to do here. It's asking us to multiply u by the scalar of 3/2. So all I'm going to do is take 3/2, and I'm going to make my u not look like this anymore. It's going to be 2, negative 1. All right? So I'm just going to multiply by the scalar. Well, 3/2 times 2 gives me a 3, and 3/2 times negative 1 gives me negative 3/2. And that's my answer. I'm done. Number 6 is a little different. It's asking us to take u and subtract 2 w's. All right, so u would be, as in regular component form, this would be 2, negative 1. right? Now, I'm going to think about this as multiplying that w vector by a -2, and I'm going to add them. So if I take my -2 times 1, it's 1 comma 2, right? When I take it out of linear combination format, right here. So when I multiply those, I have -2, -4. And then I'm just going to add them. So I have 2 minus 2 gives me 0, -1 minus 4 gives me -5. All right, consider the vector AI plus BJ. Then the direction angle measured from counterclockwise of the vector can be found by this. Tangent of theta is B over A. So what is this saying? Well, this is just indicating here, like if we have our graph and we have a vector over here, we go counterclockwise and we want to find this angle, all right? So just like we did when we did the unit circle, and we did basic trig functions, if we drew a right triangle in here, wouldn't this length right here be the horizontal component? So this would be A and this would be B, right? And then if we use B and A to find theta, we can use the trig function tangent to do that, because remember that's opposite over adjacent. And so it's going to work out where theta is the angle from the going counterclockwise. All right, so hold on, you'll see how this plays out as we look at this. Some examples. All right, so number 7 says find the magnitude and the direction of the given vector. Well, it's giving us the angle, right? That is the direction. 135. Where's 135? Well, that's over here, isn't it? 135. Somewhere over there. All right, so it's 8 times the cosine of 135i, sine of 135j. All right, so if we think about our unit circle here for just a moment, pull that back out for just a moment. Where are we at 135? Well, at 135, our I, the horizontal, the x value is negative square root of 2 over 2. So I'm just going to write 8 times negative square root of 2 over 2i plus, what is the sign at 135? Well, it's positive square root of 2 over 2j. Okay, now we have actual values there. And we can continue on. Now we can rewrite this as a vector, taking out the linear combination thing. So 8 times negative square root of 2 over 2, positive square root of 2 over 2. Okay? So let's multiply this out. Then we'll do the magnitude and the direction. Okay? When I do this, 8 times that is going to give me negative 4 square roots of 2, and then a positive 4 square roots of 2, right? Okay, there's V. This is what V is in component form. Now let's find the magnitude of V. So it's going to be negative 4 square root of 2 squared plus 4 square root of 2 squared, right? Okay, so 4 squared is 16 times square root of 2 squared is 2, so that's going to be 32 plus 32, which is going to be the square root of 64, which we know is 8, right? So the magnitude of V is 8. Now, the direction. What is the direction of this angle? Well, the angle they gave us is the direction, 135. All right, we didn't have to do any additional solving because they gave us the angle. Now, let's try number 8. Notice they didn't give us an angle here. They gave it to us in linear combination form. So I'm going to rewrite it as 8, negative 3. And then I'm going to find the magnitude of this vector. So visualize, where is 8, negative 3? Well, it's way over here, isn't it? So whatever angle I come up with, it better be pretty big. It better be greater than 270. So that's the way I can check myself. But let's do magnitude first. What does the magnitude say? Well, it's going to be 8 squared plus a negative 3 squared. 64 plus 9 is 73. So that's the square root of 73. There's the magnitude. Now to find my angle, I'm going to have to use that tangent thing. So the tangent of theta is going to be B over A. Remember, B is the vertical, so negative 3 over 8. So to find theta, I'm going to have to do the inverse tangent, a negative 3 over 8. All right? So we're going to use your calculator to do that. I can show you in class if you don't recall, but if I do inverse tangent of negative 3 over 8, I find that theta is 339.444 degrees. And then I want to make sure sure that makes sense. Does that make sense? Would 339 fall in quadrant 4? It sure would. That makes sense. Okay, so there's my magnitude and there's my direction. Magnitude, direction, we did that. A couple more examples for you. This one is to find the component form of V given a magnitude and an angle it makes with the positive x-axis. We use the following. Okay, what if they just give us the magnitude and the angle? How do we find the vectors? Well, here it is. For the x part, I'm going to take the magnitude times the cosine of the angle theta. And for the y, I'm going to take the magnitude of the sine of theta. Hopefully that makes sense because cosine is horizontal, sine is a vertical, right? So let's try one of these. Number 9 here, okay? So for V1, I'm going to take 7/2 times the cosine of 120. And for V2, I'm going to take 7/2 times the cosine, or no, I'm sorry, not cosine, but sine of 120, right? All right, so I'm going to bring in my old unit circle again. Maybe you have it memorized. That would be fabulous if you did. All right, so where are we at 120? 120 is going to give me a cosine of negative 1/2. So 7/2 times negative 1/2. The y, the sine at 120 is the square root of 3 over 2. Okay, so what does that give me? Well, remember when you multiply fractions, top to top to bottom, this gives me 7 square roots of 3 over 4. There we go. So V is, my component form would be negative 7/4 and 7 square roots of 3 over 4. And there's my answer. All right? How about you try this one on your own? And we'll start here and check this in class. All right? Good luck, and we'll see you there.